The primary sources of aircraft AC power are three 115-volt, 400-cycle, three-phase AC, engine-driven generators. Each generator has a continuous output rating of 36 kilowatts. The engine-driven generators consist of two components, the main generator and the permanent magnet generator, or PMG. Both components are connected and rotate as a unit. The PMG produces a low output voltage called residual volts. Residual volts power the main generator field, which provides the startup voltage for main generator output. The engine-driven generators are connected to the respective engines by a constant speed drive, or CSD. The CSD maintains generator frequency, or speed, at 400 cycles per second. Each CSD has its own independent oil system. Oil coolers located in the respective engine fan bypass duct use engine fan air to automatically provide CSD oil cooling. CSD oil temperature is monitored by two sensors. One sensor monitors the temperature of the oil entering the CSD from the oil cooler, and the other sensor monitors the temperature of the oil exiting the CSD. Should it become necessary to stop generator rotation on an operating engine, a CSD disconnect feature mechanically disengages the CSD from the engine. During ground operations, the APU or an external power source may be used to provide main electrical power. Backup AC power is provided by a static inverter, which converts battery power to 115 volts AC. The APU generator is identical to the engine-driven generators. However, the APU drives its generator through a gearbox instead of a CSD. An integral fan provides cooling for the APU generator. This feature allows the APU generator a higher continuous electrical load rating than the identical engine-driven generators. The primary sources of aircraft DC power are three transformer rectifiers, or TRs. The TRs convert 115-volt AC power to 28-volt DC power. Backup DC power is provided by a 24-volt NiCad battery. With the engines operating, the respective engine-driven generator powers its respective main AC bus through closed generator breakers. The synchronizing bus, which carries no electrical load, connects the main AC buses. This bus allows the engine generators to operate in parallel and share electrical loads. Bus tie breakers connect or disconnect the main AC buses from the sync bus. The number 1 main AC bus powers the number 1 TR, and the number 2 main AC bus powers the number 2 TR. The TRs directly power the respective DC buses. The buses are also interconnected, which allows the DC load to be shared and provides backup power to the DC buses should a TR fail. A current limiter, which is a fuse, protects the TRs from excessive amperage. The essential AC bus is powered directly from any operating engine-driven generator through an essential AC power relay. The essential AC bus powers the essential TR, which powers the essential DC bus. If power is not available through the essential TR, an essential bus tie allows the number 1 and or number 2 TR to power the essential DC bus. Should power not be available from TR1 and 2, a blocking diode prevents the essential TR from powering the number 1 and or 2 DC buses. Normally, the essential AC bus powers the standby AC bus, and the essential DC bus powers the standby DC bus. Normal power to the battery bus and the hot battery transfer bus is provided by the essential TR, and backup power is provided by the number 1 and or number 2 TRs. During ground operations, APU or external power is connected to the main AC buses through the sync bus, provided the bus tie breakers are closed. A second essential AC power relay allows the APU or external power to supply the essential AC bus through the sync bus and number 3 main AC bus. The AC transfer bus provides power for ground servicing and battery charging. The AC transfer bus can be powered by the number 3 main AC bus or external power when ground service is selected. The engine-driven generators are the only power sources which may be operated in parallel. APU and external power cannot be paralleled with each other or with the engine generators. AC and DC power is divided into 4 categories: main power, essential power, standby power, and battery power. Main power is required for all normal flight operations. It is supplied by the engine-driven generators through the main AC and DC buses. Essential power provides the minimum equipment requirements for flight in IMC. Essential power has no operating time limit. In flight, essential power can be supplied by any engine-driven generator. On the ground, essential power can be supplied by an engine-driven generator, APU, or external power. Standby power provides the basic power requirements needed for the captain's flight instruments and the number 1 nav-com radios. The standby buses are normally powered by the essential AC and DC buses. Battery power provides a backup power source for the standby and battery buses for up to 30 minutes. Electrical system controls and indicators for the captain and first officer are located on the center instrument panel. The following electrical controls and indicators are located on the second officer's upper and auxiliary panel. Exterior controls and indicators are located on the right side of the forward fuselage. Power from the engine-driven generators, APU, or external power is routed through the E&E compartment to circuit breaker panels located on the right-hand cockpit bulkhead and on the left-hand cockpit sidewall. The bulkhead panel is labeled P6 and the sidewall panel is labeled P18. The lower section of the P6 panel contains the circuit breakers for the heavy electrical load items. The 3 power-on lights indicate the power status of the respective main AC bus. The lights illuminate when the buses are powered. Additional circuit breaker panels are located below the captain's and first officer's instrument panels, on the aft end of the pedestal, above the second officer's upper panel, and behind the second officer's lower panel. The electrical panel markings represent the AC portion of the electrical schematic. Breaks in the lines represent the bus tie breakers, generator breakers, and field switch positions. Now let's try a few general description questions. This section will describe normal operation of the electrical system by showing the sequence of indications associated with applying power to an unpowered aircraft. The battery switch controls power from the battery to the battery bus. With the battery switch in the off position, the hot battery and hot battery transfer buses are powered by the aircraft battery. Moving the battery switch to the guarded on position applies battery power to the battery bus, the static inverter, and the standby horizon. When external power is connected to the aircraft, the external power connected light illuminates on the external power panel. The external power not in use light illuminates when external power is connected but not being used to power the aircraft. In the cockpit, an illuminated AC connected light indicates external power is connected and available. AC voltage and frequency are monitored on the AC voltmeter and frequency meter. The AC meter selector controls the selection of the AC power source displayed on the AC meters. Limitations for AC power are a voltage of 115 plus or minus 5 volts and a frequency of 400 plus or minus 8 cycles per second. The external power switch controls the connection of external power to the sync bus. The ground service position provides power for limited ground service operations by powering the AC transfer bus without powering the sync bus. The battery charger also operates when ground service is selected. With all three bus tie breakers closed, moving the external power switch to on connects power to the sync bus, which distributes power to the main AC buses. The AC ammeter displays the external power, or APU electrical load. The maximum external power load is 200 amps. The essential power failure light illuminates whenever the essential AC bus is not powered. This light is battery powered and does not require main power to illuminate. Selection of an essential AC power source is controlled by the essential power source selector. With the number 3 bus tie breaker closed, rotating the essential power source selector to external power connects external power to the essential AC bus and extinguishes the essential power failure light. DC voltage and amperage is monitored on the DC voltmeter and DC amp meter. The DC meter selector controls the selection of the DC power source displayed on the DC meters. The DC voltmeter displays the DC bus voltage, and the DC ammeter displays the DC load of the selected TR. When the battery position is selected, battery voltage is displayed on the DC voltmeter when the battery is powering the hot battery bus, and a negative reading on the DC ammeter indicates battery discharge. When the battery charger is powering the hot battery bus, battery charger voltage is displayed on the DC voltmeter, and a positive reading on the DC ammeter indicates the battery is charging. The galley power switch controls power to the galleys. CSD oil pressure is monitored by the CSD oil low pressure lights. Prior to engine start, the lights are illuminated. The CSD in and rise oil temperatures are monitored on the CSD oil temperature indicators. The CSD drive temperature switches determine which CSD oil temperature is displayed on the respective indicator. Selecting in displays on the inner scale the temperature of the oil entering the CSD from the oil cooler. This gives an indication of oil cooler efficiency. Selecting rise displays on the outer scale the temperature difference of the oil entering and exiting the CSD. This gives an indication of CSD workload. The bus tie breakers control the power flow between the main AC buses and the sync bus. The bus tie lights monitor the position of the bus tie breakers. The lights are extinguished when the bus tie breakers are closed. When generator output is normal, the generator breakers connect the generators to the respective main AC bus. The generator lights monitor the position of the generator breakers. With the generators not operating or the breakers tripped, the lights are illuminated. The field switches provide on-off control of the engine-driven generators. The field lights monitor the status of the fields. The lights are extinguished when the fields are energized. The generator electrical loads are monitored on the kW meters. The kVAR indications and kVAR button are not used by Delta. The APU may be used to supply aircraft power only during ground operations. The APU field switch provides on-off control of the APU generator. The APU field light monitors the status of the APU field. The light is extinguished when the field is closed. The APU generator switch connects or disconnects APU electrical power from the sync bus. The APU generator light monitors the APU generator breaker position. The light is illuminated when the generator breaker is tripped. With the APU operating, generator output is verified by rotating the AC meter selector to APU. With external power connected to the sync bus, prior to closing the APU generator breaker, the electrical load must be below 165 amps. Moving the APU generator switch to close trips external power from the sync bus, extinguishes the APU generator breaker light, trips the external power switch to off, and connects APU power to the sync bus. APU load on the sync bus is displayed on the AC ammeter. Moving the essential power selector to APU places APU power on the essential AC bus. During engine start, when CSD oil pressure reaches a predetermined value, the respective low pressure light extinguishes, and the CSD oil temperature indication increases. After all three engines are started, engine-driven generator output is monitored by rotating the AC meter selector switch to the respective generator position. A voltage regulator and frequency load controller automatically controls generator voltage and frequency. Prior to closing the generator breakers, moving the essential power selector to any engine generator position provides power from the respective generator to the essential AC bus. As each position is selected, the essential AC load is displayed on the respective kW meter. The number 3 generator is the normal operating source for the essential AC bus. Moving a generator switch to close trips APU power from the sync bus, extinguishes the respective generator light, connects engine generator power to its main AC bus and to the sync bus, and displays an electrical load on the respective kW meter. The synchronizing lights monitor the phase difference between the power source on the sync bus and the selected source on the AC meter switch. The sync lights are extinguished when the power sources are in phase. Generators must be in phase before they can be safely connected or paralleled to the sync bus. Prior to closing the remaining generator breakers, the respective generator frequency may be adjusted using the frequency control knobs. This adjusts generator speed and puts it in phase with the generator powering the sync bus. With all 3 engine-driven generators supplying power, the generator lights are extinguished, and an electrical load is displayed on each kW meter. When the engine-driven generators are operating in parallel, electrical loads are automatically balanced by a load controller, and generator frequency should not be manually adjusted. The maximum electrical load with all 3 generators operating in parallel is 102 kW, with 2 generators operating in parallel, 54 kW, and with any generator operating isolated, 36 kW. Now let's try a few normal operation questions. There are 2 primary types of abnormal AC power conditions: AC power malfunctions and loss of all generators. Any actual suspected or anticipated AC power interruption is classified as an AC power malfunction. An AC power malfunction may be identified by an illuminated light or a combination of lights on the generator control panel, and or abnormal CSD indication. Should a CSD's oil pressure drop below a predetermined value, the respective CSD oil low pressure light illuminates. CSD oil in temperature is considered excessive when the temperature indication remains in the caution range for more than 50 minutes. CSD oil rise temperature is considered excessive when the temperature indication remains in the caution range for more than 3 minutes. Under certain POM-defined conditions, generator rotation may be stopped by a CSD disconnect. The CSD disconnect switch controls the mechanical disconnect of the CSD from the operating engine. Once disconnected, the CSD can only be reconnected on the ground. CSD disconnect is verified by tripping the affected generator field, selecting the affected generator with the AC meter selector, and pressing the residual volts button. A 0 reading on the inner scale of the AC voltmeter indicates a clean disconnect. Should a single bus tie light illuminate, the affected generator is isolated, and the remaining generators operate in parallel through the sync bus. If more than one bus tie light illuminates, the generators power the respective buses, and no load sharing is available. Should a generator breaker trip, power is lost from the generator to its main AC bus. However, the affected bus continues to receive power from the sync bus through a closed bus tie breaker. The affected generator is still capable of supplying essential power. Should a bus tie breaker and generator breaker trip, the main AC bus is unpowered. If a generator breaker and its field trip, the generator is not capable of powering its own main AC bus or the essential AC bus. Should the selected essential power source fail, the essential power failure light illuminates. And if the number 1 main DC bus is powered, the master warning light on the forward instrument panel flashes. This indicates another source of power is available for the essential AC bus. The master warning light may be canceled by pushing the light, or both lights extinguish when essential power is restored. The second classification of an AC power abnormal condition is the loss of all generators. When power is lost to all main AC buses, a loss of all generators has occurred. If all 3 generator breakers trip, power is lost to the main AC buses. However, a source of essential power may still be available. Should all 3 generator breakers and fields trip, power is lost to the main AC buses and the essential AC bus. Should a loss of all generators occur, the aircraft battery powers the battery buses, the static inverter, and the standby horizon if the battery switch is in the on position. Rotating the essential power source selector to standby allows the battery bus to power the standby DC bus and the standby AC bus through the static inverter. With the DC meter selector in the normal TR1 position, failure of the number 1 TR is indicated by a 0 reading on the DC amp meter. The DC voltmeter displays the bus voltage, which is maintained by the number 2 TR. With the DC meter selector in TR1, a failure of the essential or number 2 TR is indicated by a higher DC amp meter reading. Rotating the DC meter selector to the essential or number 2 TR position will determine which TR has failed. The electrical fault annunciator panel provides a visual identification of certain electrical faults. This panel is used by maintenance as a diagnostic aid and should not be reset by crew members. Now let's try a few questions from the abnormal section.